Find the absolute maximum and minimum values of h of x equals x minus ln of x on the closed interval from 1/2 to 2. Now, we are no longer dealing with polynomials, so we are no longer in a situation where we can just assume that the domain of the function is all real numbers, that it's continuous everywhere. So if we look at this, of course, x is continuous on all real numbers, but the logarithmic function is only defined for positive numbers. It is continuous, so we've got no continuity issues, but we have to restrict ourselves to positive values, which we can see is not a problem because the interval we've been given is from 1/2 to 2. So we're going to use the same methods that we've been using before. We want to find that derivative so we can find the critical numbers and then evaluate our function at the critical numbers and at the endpoints. So if we differentiate, the derivative of x is 1 minus the derivative of ln of x is 1 over x. So we've got 1 minus 1 over x. Now this is undefined when x is 0, but we don't have to worry about that. That's not in our interval. It's not even in our domain. So that's not an issue. But we might have a situation where the derivative is 0, so we've got to check for that. Now we can combine these terms on the left to build them into one fraction. 1 is the same as x over x. So we've got x over x minus 1 over x equals 0, which is the same as x minus 1 over x equals 0. And this is equal to 0 when the numerator is equal to 0, and that specifically happens when x equals 1. And that is in our domain, so this is our only critical number. So we've got to evaluate the function at that critical number, and we also have to evaluate the function at our endpoints of 1/2 and 2. So when we do this, f of 1 is going to be 1 minus ln of 1. Now, ln of 1 is 0, so this is just 1 minus 0, which is 1. For 1/2, we've got 1/2 minus ln of 1/2. And we're going to need an approximation here because we need to be able to tell if this is bigger than 1 or smaller than 1. We'll need decimal approximations whenever we don't have an exact answer so that we can compare all of these values and figure out which is the maximum and which is the minimum. And when I plug this into a calculator, I get approximately 1.193. All right. And then our last one is at 2, and I've just realized that I wrote f's instead of h's. So let's go through and replace those f's with h's. All right, so our last one is h of 2, which is 2 minus ln of 2. Again, we need a decimal approximation so we can compare these. And it looks like it is approximately 1.307. I get 3068, but we can round up to 7. I'm just choosing 3 decimal places for no reason. And so we've got our 3 different answers, and we can see that the smallest is 1, and the largest is the one that's about 1.307. So those are our global maximum and minimum values. So our global minimum is 1, and it occurs at x equals 1. And our global maximum is 2 minus ln of 2, which is approximately equal to 1.307, and that occurs at x equals 2. So there are our extreme values.